Good afternoon, everybody. Hello from San Francisco, and welcome to this week's TGIK. In this episode, I want to cover more about secrets, and I want to dig more into some of the different patterns for managing secrets within the scope of the application. But before we get into that, let's go ahead and I'm going to go ahead and take care of some stuff here. All right, that was better. All right, so now I can see the live chat. Hello, everybody. Hello, Waleed. Hello, Ola from Denmark. Hello, Wade from West Virginia. How y'all doing? All right. So, you kind of see me jump around a little bit, but it is what it is. Okay. Again, welcome everybody to TGIK 66. We had to change the streams because there was some very weird configuration on YouTube that kind of knocked my house a little bit. But that's as it may be. I'm going to go ahead and put up the notes for Even More Secret, episode 66. Right here. Those are the HackMD notes for what's happening with the set. And let's get moving here. All right. So, what happened this week in review? Lots of interesting stuff happening out there in the Kubernetes space. One of the interesting edgy kube things that happened this week by the folks at Rancher was K3S. If you haven't had a chance to take a look at it yet, go ahead and check that out. It's a pretty interesting project. I mean, very I can see why this is interesting to the folks at Rancher, and also probably to quite a few of you. What this represents is kind of a really lightweight Kubernetes, but at the same time, it also is something of well, it is a fork of Kubernetes that strips out a bunch of stuff, changes the backend data store to SQLite, and could be useful for things like, small computer edge computing for Kubernetes. So if you're looking to embed Kubernetes in your environment, and you think this is the way to go, then this might be an interesting project for you to evaluate. But my concerns around it are probably very common concerns that other people have. Are this is a fork of Kubernetes, and how is it going to actually maintain track with the crazy amount of change that happens in upstream Kubernetes, weekly, monthly, quarterly? It seems like a lot to take on to manage all of that. But I'm not the one who wrote it, so we'll see how that all goes. Another interesting thing that happened this week is that Google started dropping the .dev domain. And just kind of blowing up my Twitter, people buying different dev domains. I just thought I'd give that a shout out. It's kind of an interesting thing. I think a lot of people are using these for kind of like personal websites. So if you're looking to set up a blog or you want to do anything else like that, that might be a good way to go. They're about $12 a year to pay for right now, and they're very inexpensive. I wanted to point out a couple of other interesting things that happened this week. We have Operator Hub, which actually just landed yesterday. This is an interesting one. This is actually tied into a couple of different projects that I've worked with and been around for a couple of years. This is actually representative of the work that's happening with the Operator SDK. With the Operator SDK, you'll have the ability to generate an operator for managing your software. As a reminder, folks, operators are really just kind of the controller pattern within Kubernetes, but written as software such that they can actually manage your particular application. And we're actually going to make use of an operator today, the Kube Vault operator, as we play with this and get further into the episode. So this is actually a really interesting place where you can actually register or make pull requests to show off your operator, and at that point, like folks who are running Kubernetes as an infrastructure solution can download your operator and make use of it. Very cool stuff to see that kind of continuing, starting to build a marketplace around it. I'm pretty excited to see that happen. The Kubernetes 1.14 code freeze will happen on March 7th. So if you're working in development for Kubernetes, you're going to want to be aware of that. And if you're not working for development in Kubernetes, be aware that 1.14 is coming soon to a cluster near you, hopefully. I mean, usually takes a revision or two past the first release to get to a place where we like fully trust and stabilize it. But at the same time, you know, every boot on the ground is a step forward. So let's keep that moving. The next thing I wanted to get into was, I think I've talked about this and I've referenced this site quite a few times. This is lwkd.info, and it's got it doesn't actually have a cert or something like that. But anyway, this is actually put up by Josh Burkus. This is a very cool website where folks can actually make pull requests against the GitHub repository that is LWKD. And you can actually open issues, just read through this, and like go ahead and put up things that you have seen in the community that are interesting to you as it relates to the Kubernetes development specifically. But like, so if you're working on, you know, cluster API and something really cool happened this week and you got it merged, you know, feel free to link that here. Pretty cool stuff. What I wanted to show you on the LWKD stuff was I actually noticed that last week, I was pretty impressed with this. This is a thing that I was kind of playing with a little bit while I was at CoreOS, and Eric Chang was one of my coworkers and a really great security professional out there for working on, or had worked on Kubernetes and is now at Google, working with some other friends. He actually started this idea with trying to like make it so that we could list all of the access that a particular user has with relation to their kubeconfig. So when you've been granted access to Kubernetes, you've been given a namespace. How do you know like what calls within the Kubernetes API are available to you? Right now, the only way, or prior to this change, the only way to do it would be to like literally just, you know, iterate over the world. And I actually just saw something during this last week that was called RAKKESS, RAKKESS, which does exactly that. It basically iterates over the whole world, and it just does a check to see if you actually have the ability, what permissions you have for that particular object or API path within the Kubernetes API. In this way, this is actually going to make use of self-service rules review, or self-subject rules review, which is a very different call. This call will actually result in a list of all of the rules that apply to your account rather than making you iterate through them, which I think is probably far more efficient and is also really interesting when you think about the different use cases. Like if you wanted to build a dashboard, like the Kubernetes built-in dashboard or something like that, I mean, this would be very useful for determining like what permissions to what objects the user has before presenting them. It's a very cool tool. Specifically, this ticket is about adding that capability to kubectl auth, which is a subcommand of kubectl. CANI already works, but this -list option is new, right? So this -list option would actually make the call to self-subject access review, and as you can see, it got merged. So I'm pretty jazzed about that. I can't wait to play with that. It'll probably make it into the kubectl in 1.14, I suppose. I'm really looking forward to seeing how that looks. Customize got added back into kubectl. What else did I wanted to show you this week's, or last week's, you know, what happened in last week's stuff. Most of this stuff is really just interesting stuff if you're like working on the development of Kubernetes, but I think that at the same time it's really good to kind of keep an ear to the ground as far as like what's changing in those APIs, what's being deprecated, what's graduating, and this site I think does a really good job of actually highlighting that. You can see like other mergers that have happened. kubectl autoscale is being possible or potentially supporting CRDs. That's pretty neat, kind of moving in that direction. kubeadm reset now will remove etcd nodes. There's another one. This is actually the stuff that's happening in kubeadm that I'm pretty excited about. This is kubeadm init supporting uploading of certificates. This is useful because in this model, if you were going to use kubeadm to stand up a multi-master cluster, it kind of makes it a little bit easier for moving the shared certificate material that has to be shared. So things like the signing key for the Surface accounts, for example, that needs to be the same signing key on each host, or the API server has to have a public key that matches the whole set. But yeah, like you got to be like that kind of stuff. There are certain pieces of key material that are shared across those things, and it's kind of good to know how to get to that stuff. So that is the LWKD portion of our show. I also reference, a lot of the time I reference the Cube Weekly thing that's put together by some of the CNCF ambassadors. Is pretty cool stuff, and they kind of highlight like the headlines, some things that have, interesting articles that have happened. Oh, you know what, I think I'm looking at a specific one, and I only want to look at the latest one. There we go. Well, I'll figure it out one of these times and put it in a link. But out of that Cube Weekly this week, I found a few interesting articles. What was happening? One of them actually I thought was interesting is this podcast from Software Engineering Daily, and they actually cover a lot of really interesting things in their podcasts. And Software Engineering Daily is a relatively new thing for me. I'm sure, like some of you probably are already aware of it. But what I've been seeing is that they've actually started having on folks like Liz Rice talking about Kubernetes security. They've got some other stuff on Kubernetes, the Knative serverless workloads, VMware Kubernetes strategy with Brad Measles. There's lots of interesting things happening around here in this on this website, Software Engineering Daily. So go check that out. That's pretty neat. The next one. Yes. So last time I saw you, they had actually just dropped that Run C CVE, and that was actually addressed by a lot of things. Let's take a look at this one. This was put up in Discuss. CVE, denial of service attack was reported in Kube API server, in which authorized users with write permissions can cause the API server to consume excessive resources while handling a write request. So, I mean, basically, this would allow you to basically make the API server so busy you couldn't do other things or affect other tenants using the same cluster. Interesting vulnerability, and it's here. It looks like it's been fixed in 111.8, 112.6, and 113.4. And presumably in 114 as well. So medium severity, nothing is quite as blow the wheels off the bus as we saw earlier in the last time I saw y'all, which was the Run C vulnerability. So let's check in with our chat here, see how y'all doing. Got people who are very interested in K3S. We got Antoine from Paris. How's it going? And it does conform with CNCF Kubernetes. It's actually pretty impressive. I mean, like as an experiment, I'm like really impressed with what's happened with C3S. All right, and let's get back to our notes here. Okay, so the next thing, yeah, Rockcast was the piece I was talking about, and this one is an interesting one. It's a really cool kubectl plugin that allows you to effectively do exactly what we were talking about in that chat. And I mean to open a ticket against Rockcast to make him aware of this, not just talking about it in the broadcast, but also actually putting this up. But what I noticed inside of the packaging was in the client side, the check access code here is actually just iterating through using CSRs or it's iterating through all of the things that you have and all of the permissions that you could have over the entire space. And so that's actually not a terrible way to go about it, except that you can imagine that that's a pretty significant load for the API server, and at the same time is bound to be somewhat incomplete, right? Because like unless you're actually dynamically generating all of the permissions and all of the CRDs and everything else in the scoping of your call, it's going to be difficult to actually get the entire permission set. Whereas built into self-review rules, you have the ability to actually enumerate all of that stuff. Very cool stuff. All right, that is the first part of our show. Let's see what else. Let's see what you all are up to. Yeah, Chris is getting better. She's not had a climbing accident. She's just taking care of herself and get better all the time. We got Timmy checking in. We have a related CVE today from KOps on 111.1 to address that. Oh, interesting. And yeah. All right. The next part I want to do in here. So first I want to talk a little bit about like secrets and that whole surface. And this is you're just going to hear me expound on this for a sec. I'm going to kind of talk through this whole thing. So secrets are a really interesting topic, and I broached it last week a little, or I guess 2 weeks ago now, a little bit with like, we talked about like encrypting secrets at rest in Kubernetes by either making use of a KMS provider or by, or even just providing like an AES string that can be used to encrypt all those secrets at rest. If we think about how all that works, like the way secrets are exposed to pods are still somewhat are still like within the scope of the cluster itself, and that means that if I tried to like really constrain what can have access to those secrets, I'm still relegated to keeping within the constraint of the cluster's RBAC model and through those things. Now, the challenge with that is that it means that, like, for example, I mean, while Kubernetes does have audit logs and there's a lot of capability there, it makes it somewhat more challenging, I think, in some ways to understand like what's actually accessing a secret. And in many ways, because of the way that secrets are persisted to pods, it's challenging to rotate those secrets. If I needed to actually rotate a secret, which is really the only way to keep anything secret, which is just not to let it live forever. Like you create a secret, you have that secret for a period of time, and then you go about rotating those credentials. And there's tons of patterns out there for how to do that with like Vault and many other and a variety of other tooling that is out there. But really, what I wanted to get to was like, if you're going to actually generate a secret, there are kind of two principles to keep in mind. One principle is how long is that secret going to be good for, in case it gets in case it becomes exploited. If somebody gets a hold of it, right? Like what is your fallback plan? Like what do you do if somebody gets a hold of the wildcard cert for your corporation, right? That's a wildcard cert. That means that anybody could impersonate your corporation. And the first thing that a lot of people think about when they think about that kind of security surface is they're like, well, I just need to really lock it down and only make it so that certain entities can have that wildcard cert. And really, like, I think, in reality, like locking it down can only get you so far, like, because inevitably you still have the kind of the challenge that is everybody is a human, and you have like the ability to, like make a mistake and leave that wildcard cert while you were troubleshooting something or debugging something. You could leave that cert in a place that it is vulnerable, and somebody gets a hold of it, and now that cert is going to be a risk to your corporation the entire time of the length of that certificate, right? And that's challenging. So if we can't rely on people to secure secrets, then like what other tools are at our disposal? Things like Vault, things like in this certificate case, the ability to actually ensure that a certificate has a short lifetime. If I was going to make a wildcard cert for a thing, it would behoove me to ensure that that wildcard cert had a short lifetime. Maybe 10 days, maybe 20 days, maybe a month, even shorter if I could get away with it. And the benefit of that is that I can greatly reduce the exposure of that secret once it is out there in the wild, right? Like you got a hold of a secret that had 2 days left. You know, make those 2 days work for you, because that's all the time you got to really to impersonate something at my corporation, right? So there's that piece of it. There's also the piece of it like where, again, like I said before, if you use Vault, there's like lots of patterns out there for like ensuring that you could issue a token that would provide you access to a thing, and then you have some capability to actually rotate that token on a regular basis. And a lot of the, you know, kind of the newer stuff inside of like access management has actually kind of been expanded to support this whole idea. Like if you look at OIDC or OAuth 2, they have the idea of like a refresh token. You'd have the ability to issue a token, have that token be time bound, and then as part of the protocol, they actually support the idea of rotating these tokens. So when we look at like different ways to keep things a secret, the first part we have to really think about is, you know, what is the artifact of that secret, and what can I do to provide governance or control over that secret such that if it were, I should say, when it becomes exposed, I can reduce the attack surface that secret would provide for consistently, right? And that's super important. The second topic I think that's important, especially when it comes to Kubernetes, is like, how can I reduce the number of consumers of that secret, of that artifact, as small as possible? Like, how can I get to the point where only the thing that needs to have that secret, like this, like the only the thing that needs to have that secret can get to it, right? If I put a secret inside of Kubernetes, my point was that like this exposes that secret to anything within Kubernetes by default, right? And obviously there's lots of capability within RBAC that we can use to kind of limit access to that secret, but and there's also what we showed you last week, or I guess 2 weeks ago, which is like things where we actually limit the ability for the node to access a secret. So if somebody deploys another pod on that node, if that secret is not available to the node already, you wouldn't be able to get a hold of it. But all of these things are pretty easy to kind of punch big holes in as far as like the security posture or the security part of it. And so really what would be better is if you had a way to ensure that your application code had some form of identity and had the ability to go and authenticate with wherever your secrets are held or being issued from. And then you would go about like, ensuring that you get that secret as part of your code, right? Like as part of the running code inside of your container. You would have the ability to authenticate to that entity that the secret is held in. You would get a secret that would issued specifically to your application for perhaps a period of time. When that pod is actually, when that pod goes away and the new pod comes up, that new pod as part of its init state would actually go out and get a new secret or have a new one issued. And that is like kind of about the most secure way to actually manage secrets within Kubernetes, right? If you can get to that point where you're doing it at the code level, that is going to be probably the most secure way to go about it. What I want to talk about in this episode, when we get our hands-on part of it, is I'm going to show you Kube Vault, which is an open source project put out by Apps Code. And this one actually gives us both the ability to stand up Vault, which is pretty cool. It also gives us the ability to reason about. It also gives us the ability to reason about secrets as they're held in like kind of a container storage interface, right? So in this way, we can actually store a secret inside a vault, and we can actually make use of a volume that is mounted to my pod, where the secret would be made available only to that pod, right? It's not using the mechanism to get hold of secrets inside of the Kubernetes construct, but it's actually ensuring that the secret that it's going to go fetch is actually only available to my pod through a mounted volume that only the pod has. And that's a pretty secure way. And that's kind of like, if we think about these levels of, we think about these levels of surface, right? If I expose a secret, encrypted or not, inside of Kubernetes, that's a pretty wide surface. Lots of things have access to that secret. If I expose a secret to a volume that only pods have, that greatly reduces my surface, right? It means that only that pod has access to that volume. And as long as I have a reasonably secure way of ensuring that that volume is only available to those pods, that would greatly increase my my surface, or greatly reduce the surface of of attack there. And then the third one is, what if only my application had the access to a secret? And that's probably the least surface that we can define, right? Like, you'd still have the risk of somebody execing into the pod and getting a hold of the secret, or exposing the secret through exploiting the application. But again, as long as you're thinking about that ahead of time, if you're thinking about the fact that any secret has to have a shelf life, no matter what, like, you can't have a cert that lasts 20 years. It has to be a certificate that is only going to be good for a week, right? And that's where things like Let's Encrypt and a lot of these other toolings out there, and even Vault, like, give you the ability to kind of issue certs that have a shelf life and can be rotated. All right, that is enough of me rambling about this. Let's see what y'all think about my rambles. All right. Okay. Mr. Rory, he says, agree with the piece about controlling secrets. One thing to think about with secrets management is that once you use it, you need to be very sure that secrets management software is secure. And that's very, very true. Yeah, like so. And that's kind of what I was alluding to before, right? Like, if I use KubeVault to automate the generation of a secret and make that secret available to my application through a mounted volume that my application can presume is going to be present, right? Then what's going to happen when, like, how can I ensure that the content of that secret is, that mechanism with which I actually specify the secret and the mount path is controlled, right? I don't want to make it so that anybody can mount that secret, or I haven't improved my security at all, right? I also have to think about, like, how does Vault store secrets? Is it storing them encrypted at rest? Is it storing them encrypted at rest? Is it ensuring that the encryption mechanism being used to get the secret to me from the, how do I actually access that container storage interface? Is that model also secure? And just kind of thinking about all the different ways that those secrets work, and like what kind of controls you have around auditing and enforcing the constraints that you might want to put around that sort of stuff. So that is what I want to talk about there. So KubeVault is going through a CSI driver piece, and I think that's actually pretty cool. We're going to actually get hands-on here in a minute. I've stood up an EKS cluster. We're going to play with that. The other one that I actually linked before and was talking about is the KMIS tool by Omer and Saluto Engineering. This is another interesting project that's out there to kind of solve this problem. And we're going to play with this one probably right after we get through the Vault one, if we have time, or depending on how one or the other one of them goes. But both of these actually have their strengths and benefits. This one doesn't actually use a CSI yet. I think that they may be working on it. I'm not totally sure. But yeah, check out this article. Check out the threat model. This is actually one of the few projects I've seen that has a threat model. Vault also has one. But pretty neat stuff. Like, it actually, very, very cool project. So let's get started with where we're at with all of this stuff. So I wanted to all right, let's get going with KubeVault docs. So I am going to get moving here. Could you share? Wait, you only see, oh yeah, good point. Thank you. 3. Make sure that's actually working. Yeah, 1 second. All right, now you can see my screen. Thank you for calling that out. That was the end of my rant. Now you can see my screen. These were the pages I was talking about. I'm afraid I didn't share those with you, but I was actually clicking through this stuff the whole time and you weren't able to see it. I apologize. Anyway, let's keep moving. So I'm going to start with the KubeVault docs, and they're here on github.com, KubeVault docs, and I'm sure they actually also have like a website where this stuff is registered. I'm just using it just to play with it. So I'm going to click through on this. Oop, there is a link problem. Okay. So I'm going to click through here and I'm going to start kind of playing with how all of this works. These are the docs that are available to me. And so I'm going to start with like, so what I've done already, I should say, is I've already spun up a cluster in AWS using the VMware Quick Start, or by Heptio. Used to be the Heptio Quick Start. So I have my cluster already running here, and if I spin up a shell here, we can see our Kubernetes cluster running. We can see it's running. You can see it's running Calico. We got Core DNS. We got one single master with one single API server. All of that stuff that's running, and I have already deployed the Vault operator. Well, the Vault operator is the operator that will manage all of the Vault servers and stuff that I wanted to create. So that's what we've got so far. And to talk about how I'm doing that, basically this was I stood up the again the Quick Start cluster that I pointed out already, and in AWS I went ahead and deployed the operator using this mechanism. Actually, I put it on my master, so I did this one, right, which is basically run this on master. When you deploy this operator, it's actually pretty interesting. They provide you a lot of options for like what you want to do here. So if you wanted to, for example, host the images that are that are being used in the Vault operator locally or on your own private repository, you could do that by basically providing the image pull secret and the Docker registry command line arguments. If you didn't want to keep the operator in kubesystem, you want to put it somewhere else, you can just specify the namespace. And then they're really cool. This is actually one of the few projects I've seen that actually makes use of this. Is they actually make use of validating webhooks and mutating webhooks to ensure that when you're creating these objects that they're conformant with the spec of the object. So they're doing all of that in webhooks. Pretty cool stuff. You can specify the Kube API server FQDN for other things. You can enable analytics, which is true by default. You can do an uninstall or a purge, and you can install the catalog. Again, it will automatically do that. There's a monitoring agent, a monitoring operator. These are all options that you have when deploying this operator. So I've already got this one deployed, and here are the images that it's going to use. And it's mainly because I want to kind of spend more time kind of looking at the creation of the Vault and kind of getting down to the place where we start playing with this the CSI way. So as I said, this is already deployed. So if I get back over here. Yeah, so we can see that the Vault operator is already there. The other thing I've actually deployed is just a pod, get svc-n, and it's this pod is going to give me the ability to see environment variables that have actually been put up. So in, again, kind of against the whole, well, as an example, I guess, of the risk of environment variables and those sorts of things. What I'm going to do later on in the episode, when we actually mount a secret in through the CSI, I'm actually going to use this little application to show you the secret that's actually been exposed in my environment variables. And this is this is some of the early security problems of things like Java and PHP and many others. Is if you leave a debug page on, a lot of the times it'll print environment variables, and you've got to be careful with that kind of stuff. So let's get into the next piece of this. I'm going to go ahead and stack these two. So the next thing I want to do here is I want to actually create a vault using. So I've already done the creation of the cluster and that stuff. Let's go ahead and create our vaults. Already done that, did that, yep, all good. Now you're ready to deploy and manage Vault using the Vault operator. Okay, so deploy Vault on Amazon EKS. That's what I'm going to do. Mainly, I'm not using EKS. I'm just using Amazon. But like in their example here, they're referring to this as EKS. So let's go ahead and create our demo namespace. I believe I already have it created, but let's take a look anyway. kubectl-ns. I've already got a demo namespace created. If I do kubectl-get pod-demo, nothing in there. So the next thing I want to do is I want to go ahead and, well, that's kind of a weird ordered thing. Yeah, we've already got our bucket, we've already got our key, we've already got our cluster. Let's go ahead and get to this part. Wherein we're going to have to like probably edit some of these fields because my cluster's in a different place, but we'll get to it. Let's go ahead and do that now. So what this is going to allow me to do is it's going to allow me to create a kube vault, a vault server, effectively, leveraging the operator inside of the vault operator that I have deployed into my kube system namespace. And so we're going to kind of walk through how all that works, and play with that. So, oh, one more thing before I get too far is down here at the bottom of this document, there's actually example IAM policies, SSM policies, and KMS policies, and I had to apply these to my node role where the vault will be deployed to actually get the stuff to work. And so I just wanted to call that out. That was actually a thing that took me a little while to actually get wired in correctly. But yeah, you got to have the policies if you're going to make use of a node. They also provide you the ability, and I didn't look into this, but if you wanted to actually issue a different account within AWS that would have access to those things, you can actually use that account credential directly for those things. And so you don't have to necessarily use the node role if you want, then there we go. If you wanted to actually provide a credential for the S3 bucket and a credential for the KMS and SSM permissions, you can actually separate those permissions into two things. You can provide a credential for each of those and then just provide that to the spec. And so that's actually pretty cool. I kind of like that it's as flexible as that. What that means is that when you're actually generating the vault and you're providing the secret, you can actually or the credential to use to authenticate to AWS, you can do it that way, which is pretty nice. All right, let's go ahead and copy this guy, actually the one here at the top, and then we'll put that into our workspace here. So. Now I know AWS vaults. So I've got my credentials stored here, and I'm already able to log in. So what I have, let's go through and see what we have created. So in the docs, they're saying that I need to have an SMS key already, or a KMS key already generated, and that I also already want to have an S3 bucket. And so I have created a bucket called devault1212, and I have created a KMS key with this key ID right here. And so inside of my vault.yaml, West 1. Okay, so I'm going to create a vault here. But actually, before I do that, let's go back to our docs, because they refer to one more thing that we should do, which is basically like what we're looking right now. What we're looking for right now is basically all the parameters that we need to configure this vault. So let's go ahead and run this command. And this will tell me what version of vault I want to deploy. Let's go with that. Looks like I have 101 and I have vault 0.11.5. So I guess I'll just go with 0.11.5 here. There you go. 5. Okay, so we got vvault 1212, US West 1, US West 1. There's my KMS key ID. And deploy, create. Let's see where that gets us. Kubectl get pod dash n demo. Oh, it's running. Okay, cool. And then we'll do logs dash n system. Let's look at our vault operator logs and see what's happening here. Might be kind of cool. Looks like things are plugging away. Let's look at what's happening with the pod on the demo namespace. Key store value for vault root token already exists. I think what that means. Oh, I did actually. Yeah, I know what this is. So I stood this up earlier, trying to make sure that it would all work for me. And now what's happening is that I already have a value that has been created. Let's see what you all think of that. Yeah, the crowd roars. Okay, screen okay. Awesome. Thank you, George. See you later. So yeah, so what this means is that like the key, the token that's actually stored inside of SSM is actually the thing where that's messed up. So let's go ahead and clean that up. Over here, parameter store. There we go. Yeah, so these are the keys that were already generated. I'm going to wipe these out. And then I'll refresh. Hey, and they're back. How about these are the new ones? Let's go back to our logs. And it's initialized. All right. So now if I do my kubectl get vault server dash n demo my vault, I can see that it's in a running state and it's running version 0.11.5 and there's one node of it and it's about 3 minutes old. So let's go ahead and do some other checks and make sure that this vault cluster is doing what it says or what we're expecting. So we got our vault here. We've already done through this piece of it. We see that it's in a running state, which is awesome. Let's go ahead and take a look at this, the output of this command. Yeah, so we're good there. Everything seems to be working. let's cruise on down to get services, which I believe is actually working as well. So right now we have a vault stood up and it's working. So if we do cube get svc-in demo, we see our vault service here. We can see that it's all tuned up here. So it's actually listing on cluster IP, so it's only available within the cluster, and that's probably for the best. Let's see what else we got here. Configuration can be used to see the, oh, here's the configuration for this particular vault instance. Let's take a look at that. See how we've actually configured it. So we do kubectl describe config map -n demo. We can see from the configuration that we've configured it to listen on any interface on 8200. The cluster address is listing on port 8201. There is a cert and a key file that's being used to secure those interfaces. We've configured it to use as storage the dvault 1212 bucket in US West 1, which is awesome, which is what we expected. And telemetry has been configured. I'm actually curious about this certificate, so I'm going to take a look at that certificate because I'm actually curious to see what's happening there. So this is related to a secret, get secret-in demo. So this is the thing that's actually going to be used to encrypt traffic, or encrypt traffic back and forth on the wire between myself and this vault instance. Get secret demo -yaml. That's what we were talking about before, right? Like I am an administrator of this cluster, but I have access to I have access to all the secrets. You would have a record of me doing a get of this certificate, but here is the key and the certificate. This is not uncommon inside of Kubernetes to host those things as secrets, regardless of their current state, or regardless of whether secrets are a good idea or not. And you could imagine that if we were going to try and use this for it, our problem would be that we'd have a chicken and egg problem. We'd have to have some mechanism to allow for this running pod to have a secret before a secret could be stored somewhere. So let's take a look at this secret. And this is actually a pretty interesting way to go about this. It's going to bear with me. What I'm doing is I've grabbed the entire base64 blob for the TLS cert, and I'm echoing it, and then I'm going to pipe it out to base64 -d, and then I'm going to pipe it out to OpenSSL X509 text, because I want to see what this is configured to do. This is a good way to actually understanding secrets generally at all, right? Like this is a very cool trick for understanding certificates at all. So if you want to look at a certificate and see how it's actually, what it's configured for, this is a pretty decent way to do it. So inside here I can see that this one is actually issued the web server authentication, so this is actually going to be a serving certificate. It's going to be a certificate that is protecting a listening interface. It's not meant to be used as a client certificate. And that when I interact with the interface that is using this certificate, it will allow me to address it with one of the following names. I could call it localhost, I can call it anything.demo.pod, I can call it myvault.demo.service, and I can call it by the IP address 127.0.0.1. So what that means is, like, if I was going to do a curl, or if I was trying to authenticate against this certificate, this certificate will ensure that that the host name that I'm actually using, has to match one of these subject and alternate names, or it'll error out on my browser. Now, the funny thing is, I'm not going to use a browser to interact with this. I'm going to use a client, and this is the same thing is true for clients as well, right? If I don't ensure that the host name that I'm using to and pointing at a particular endpoint is in line, then it'll still throw an error. So we've looked at the way this is configured. That's pretty neat. We can see our secrets that are in there. Oh, and it goes on to tell us to look at the secrets. That's pretty cool. And then we can see the unsealed keys and root token in the parameter store, which we already saw. That's there. And then let's get into using Vault. Now, how is it going to do this? How is it going to ensure that I can get a hold of the token, but not everybody else can? Like, that'll be interesting. So, what looks like it's going to happen is it's telling me that I can go ahead and get the Vault root token from the parameter store, and then I have to use AWS KMS to decrypt it. So it's not stored. So the Vault root token is not stored, and presumably none of the shares are either, in the parameter store unencrypted. They're all encrypted individually with the KMS key that I'm providing, and that's pretty neat, right? So then I can leverage AWS to ensure that only certain people or entities have access to that KMS key, and that's pretty cool. So let's go ahead and go through this process. And what this will allow us to do is actually grab or authenticate to Vault, which we cannot currently do. So let's see. All right, so let's grab our root inc. Oh, US West 1. If I look at that, oh, it's an encrypted text, right? So I can't actually access it the way it is, but I was able to actually grab that parameter off of the SSM. So now let's go ahead and decrypt this guy. Except that it is US West 1, and there is my token. Let's go ahead and export that. So export. That'll set this in my environment where I can actually use it to authenticate to the cluster. Before I can actually hit that guy, though, I want to do port forward. Like, it's not exposed to the outside world. It's only exposed within the scope of the cluster, and even its certificate is actually limited to that, to exposure within the cluster. So for me to actually get to that vault and interact with it, I'm going to have to do some port forwarding magic here. So he says go ahead and forward port 8200. So let's go ahead and do that. So we'll do kubectl get svc-n demo, kubectl port forward svc my vault demo 8200. I don't think I have that listing locally. And the way port forward works, you can actually have port forward point to a particular pod or to a service. If you do use a service, it will actually resolve one of the pods on the back end of that service the first time, and then henceforth all other connections will go to that same pod. It's not going to like balance. It's not making use of the cluster IP mechanism, and that it's going to balance across those things because it's just a single session that you're standing up. So I'm going to go ahead and start this up. Also, if I don't specify another port to forward to, that means it should use the same port for both parameters, and this will make it so that I'm port forwarding this application across this service on my local 8200 port. Oop. Apparently, I already have it running somewhere. So let's see. pgrep kubectl. There we go. All right, so now we have my port forward going to that application on port 8200. Let's see if we can get a little further down the road here. Since I don't have the CA that was used to issue that certificate, I'm going to just go ahead and do skip verify. What this means is just trust the cert that you're given. Don't ask so many questions. and not really probably the best thing. What would be cooler is if you had a way to actually ensure that you had the CA certificate or a copy of the CA certificate that signed that, or that you issued that certificate yourself. I haven't actually looked into like how that could be done with this yet. Maybe we'll get into that after this. But so we have exposed our token. We've got our vault skip verify true. We've got our vault address. So now I guess let's try vault status. Vault status. It is not in HA mode. It's using the seal type. It is not sealed currently. There are 4 shares with a threshold of 2, and it's all working. So that's pretty cool. Let's see. Now that we have because we have our token already in our environment, let's run through some of the rest of this demo here. Do vault secrets. So we can see the secrets. Can we create a secret? Let's try that. It looks like it works. And if we do get, we can see that. And if we do delete, yeah, cool. So that all works. So we are now able to authenticate with our vault. So we got our vault working. So let's hear the cheers for that. That's pretty cool. Let's go ahead and see how we're doing here. Anybody? Hope you're all doing well. I'm not seeing a lot of feedback on the chat. So just let me know if you have questions. I know it's a lot of information, and I'm trying to cover it in a pretty cohesive way. So let me know if you have questions, or if I'm not covering something, or anything's not clear. Happy to get to it further. Before we leave this page, I kind of want to look at the defined CRD for this object and see, like, is there a way for me to configure this? Like what's the CRD look like? And so here is the spec for this. We have, we can actually specify TLS bundle. So if we already had secrets that were, or if we already had certificates that we had issued as a corporation, we could actually leverage those certificates. They do have some constraints though. Like if you can provide them the certificates, but if you want to do so, the expectation is that the following will be encoded in, right? You'd be able to reference this vault service as an internal service. And so these are kind of like the mechanisms within Kubernetes that allow you to do discovery, right? So they want to make sure that you have namespace pod, that you have vault namespace service, and I presume that this is probably a requirement because this is actually how the operator itself would understand the health of that vault server that it is managing, right? Like it has to have some way of actually discovering that entity, because these vault servers could be stood up in multiple namespaces, and the vault operator needs to know when things go bad so that it can fix it up. You have the ability to specify a config source. This is an optional field that allows you to provide extra configuration for Vault, which is pretty neat. So if you have like more to the HCL that you want to put in there, you can do that. Spec backend is a required field. Oh, it tells you where to put it. I was actually just using S3, the S3 bucket in the example, but there's like a lot of other options. You can do in-memory, Swift, you could use etcd as a packaging store. Lots of options here for Vault. And this is actually specific to Vault. This configuration option is specific to the configuration of the Vault server as it relates to KubeVault. It's a very cool project for helping you manage Vault secrets. Then you have this thing called spec unsealer. We already ran that command, but let's take again a look at my vault. And so our spec unsealer must be the default. I don't see it in here. And what it tells us, like how many secret shares there are, what the threshold is. Presumably it's like 4 by default and 2 is the threshold, and then how many times to retry, and over what period of time. Then you have your template, whether it's a node port, whether it's a load balancer, what the source ranges are. Lots of really great stuff written into this spec that you can use to really tightly constrain like what has access to that particular vault instance and who can authenticate to it. Where you want to run it is an option. What the image pool secret for getting the images, the resources that you want to allocate to this particular pod, so you don't have to. So it wouldn't run. So you can say like this is going to take so much memory and so much CPU. That way you have some rational idea of actually understanding resource utilization within your cluster. You have auth methods. Oh, this is pretty cool. I should have actually turned on the Kubernetes one, but optional field. And if you think about it, like these are all parameters that you would use like normally in configuring Vault, right? Nothing here is specific to the Kube Vault implementation. This is just the Kube Vault implementation supporting those parameters that would be made available to you or exposed to you if you were going to deploy Vault on your own, like on a server. And these guys are just making it a lot easier to reason about all of those parts, which is pretty cool. So our Vault status is actually the status field for that Vault, and we have already looked at that, but let's look at it again. Get Vault server -n demo -o YAML. And so here's our Vault status. We can see that it's unsealed, and that this particular Vault is active. Oh, it looks like auth method status path is Kubernetes. It already enables that, presumably because you're deploying it to Kubernetes. So that's pretty neat. So like, as we get into the CSI stuff, we won't have to actually wire that up. So yeah, I mean, like lots of really cool stuff. And like the Vault status, I like that it actually goes through a transitional period, like whether it's active, standby, or being initiated. There's lots of really good stuff written into this spec. Let's move on here to the CSI driver. Why don't we use, we're going to make use of the key value secret engine in this CSI. So before we begin, we're going to have to, so this will be kind of like the part that I have not explored at all prior to the show. So this will be kind of a fun part that we hack through in this week's episode. In this week's episode, we're going to basically, we're going to make use of this. What this will allow me to do is actually define a new container storage interface class, and hopefully what this will allow me to do is ensure that I can actually access secrets that are stored in Vault using my credentials and make them available to pods that I'm running inside of my my cluster using using the CSI driver. So there are actually YAML files located in here. We've already got a Vault created. App binding required to connect CSI driver to Vault server. I think I'm probably going to need a different tool for that. I don't think I would have an app binding resource to manage that. We've got our Vault server already stood up. We've already got KV working because we were able to authenticate to it. So we already have Kubernetes Vault. We already got Kubernetes authority set up in our configuration. You know what, I'm going to check out this repository that they're referring to and use the repository to get my stuff. So where's the repository? GitHub repository Kube Vault docs. And these examples are under docs examples, CSI driver KV. Docs examples. Nope. So what is an app? So these are the things that they're asking us to create. We're going to go ahead and we're going to walk through this policy, walk through this stuff, and make sure that it all kind of makes sense. But it'll be interesting to kind of figure this account. So we have our CSI service account. So this is asking me to create a service account with auth delegator. I might actually already have this set up on the vault in our environment. So let's do kubectl get sa-n demo. Let's see, vault demo. I didn't put a full path there. That was my bad. Let me fix that up real quick. What I'm doing is I'm just editing my envarc to actually give it a real path. And I'm going to use my DRM to allow it again. Again, if you haven't seen DRM, or if you haven't seen DRM.org, definitely worth checking out, just as a side note, or DRM.net. Very cool tool for managing environment variables as you move in and out of directories. Very, very handy, and I use it a lot. So let's go back into our docs, examples, CSI driver, KV. Okay, so what we were trying to figure out is like, is this already set up? Like how far, where are we already? So if we do kubectl get sa-n demo, what do we got? We already have my vault and my vault token reviewer. So we're probably already there with a service account. It was trying to create KV Vault service account. This is probably for the use of the CSI implementation though. CSI storage class. Secret CSI provisioner. Yeah. Yeah, okay, that makes sense. So what this is ensuring is that we have a mechanism, a service account that the, hold on. Vault KB storage, it's actually not referencing the that's the secret that we want to create. Okay, let's go back to our docs and just read through this real quick. We've got vault configured. We don't likely have that, but let's take a look at that. We have a role using this CSI driver can access credentials from the, we have that. There are two ways to configure vault server, vault operator, vault CLI. Already got that part all worked out. To read a secret from the engine, we need to create a policy that has a read capability. Okay, so here's where we were with our service account. So they want to create a service account in the demo namespace that has token auth. So this is actually the service account that Vault presumably is going to use to authenticate, or is going to use to review the token provided by the caller to ensure that they have access to it. So let me back up a sec and kind of talk through what's happening there. A lot of this has already been taken care of for us, but let's talk through what's happening. Vault can use a variety of different forms of authentication to provide entities access to secrets, whether that means read-write access, whether that means read-only access, or even access to a particular subpath or set of secrets, right? But how do we actually identify those users or consumers of those secrets, or even the creators of them? How do we actually get a list of things that are going to try and authenticate to Vault? By default, we could use a token, which is actually how we're authenticating to Vault in our command line, right? So like when we actually, there will be an admin token that is generated, and that admin token has the highest privileges of anything inside of Vault. And that's the token that we were using to interact with Vault earlier. But we have a variety of other options, including the ability to leverage service accounts in Kubernetes as a mechanism by which we can authenticate to Vault. Now, the way Vault does this is actually pretty neat, but let's talk through it real quick because I think it's actually kind of interesting. So the way this works is that with the Kubernetes, and actually, you know what, I'm going to show you the Vault Kubernetes documentation. I believe that some of this was actually already covered by a Vault conversation that we had earlier in the year, but if it hasn't been, then we're going to cover it here. So when we enable this, what we're actually enabling is the ability for you to use a service account to authenticate to Vault. And then once you actually have authenticated to Vault, the response will come back with an auth client token. Now, that auth client token represents the token that you will then use to interact with Vault. So let's walk through that flow again, just to make sure it's really clear. So I can use my service account to authenticate to Vault. And that authentication mechanism, right, will basically ensure that Vault sees my service account as an entity that has access to this particular Vault. But what permissions, like how do I authorize, or how do I actually from then on authenticate to go get a secret? How do I actually, what token do I use to say that Vault command earlier that we saw, Vault get secret foo, right? I would not be able to use my service account to do a Vault secret foo. I can only use my service account to authenticate or log in to Vault. Once I've logged in, it will issue me, upon the period of that login, a token that I can use to then interact with Vault as my credential. So it's like two things, and it's neat because if you think about it, that service account is something that's shared across the entire cluster. So I don't really have a good understanding of who is using that service account. Sorry, not the entire cluster. That service account is available to anybody within the namespace. And so anybody can use that service account to authenticate to Vault and get this token. But for the audit log piece, this is actually pretty compelling because it means that like any call to go get a secret or to create a secret or delete a secret, I can understand what client token made that happen. And as part of the Kubernetes authentication piece, it's going to return to me a lot more information about that client. So pretty cool stuff as far as like what you can actually do. But yeah, to go over it the third time, for magic is you're going to use your service account to authenticate to Vault. Vault will provide you a token. That token is the thing that you will be able to use to do Vault get secret, Vault delete secret, Vault put secret, all those things. And what's interesting, when we think about the way the CSI works, the CSI driver for Vault is actually going to be doing all of that work. And so it would be interesting to see how that works. Let's keep going. So this is already set up on our part. We don't have to worry about this piece, I don't believe. And we already have a token reviewer. So if we do Vault get auth Kubernetes config, let's see what we look at. Right, so Vault status, cool, still working. Ah, looks like it isn't wired in yet. It only has the host and the CA certificate. Okay, so we do have a little bit more work to do here, I think. Okay. Let's take a look at our chat, see how you're all doing. Okay, looking good over there. All right. So let's keep going with this piece of video. So it turns out it looks like this isn't completely configured yet so for my part, I'm actually going to continue down this path here. Let's go ahead and get this set up. So let's create our policy. I believe that's already turned on, but let's do it anyway. Okay. Let's go apply that policy right. Okay, we got our policy uploaded. Go ahead and do our secret. I want to create a service account. Let's go ahead and do that, and then we'll go through this process. Token from the JWT, the host information. Yeah, like right now, all I see is in there is the host information. I don't see the JWT, which is surprising to me. So let's keep going on that part of it here. So first, we're going to go ahead and create the service account. kubectl create-f CSI service account, and then what they want us to do next is basically pull out the JWT, the SA name. We'll look at what this command is doing. So it's going to do a kubectl get service account KV vault in the demo namespace, and it's going to grab all secrets with the name, the name of all secrets. So if we actually just echo vault SA name, so that's the name of the token that is going to be the secret holding. That's going to be the secret holding the information for my stuff. So now they want us to grab the token, so let's go ahead and do that. And if I echo that, so this is the JWT token that was issued for that service account, and that's pretty cool. We can kind of see how that's happening, right? So we already know the secret name. We're in that same namespace. We're just doing a JSON path to actually grab the token value, and then we decode that, and that's pretty cool. So because it is actually stored in base64 format. So now we're going to grab the CA cert, which I think we actually already have uploaded, but let's go ahead and grab it anyway. So there is our certificate, and we already have the host 6443 configured. So now This is our next command. I believe it's already enabled, so, but we're going to enable it again anyway, because that's how we roll. But we saw in the logs that it was already enabled. Path is already in use, see? So we know that it's already there. So then let's grab this config. Oh, sorry, let's grab the output as well. So what this is doing is it's writing to the auth Kubernetes config path, the token reviewer of that JWT token, the one that we saw right up here. And it's also going to grab the, it's going to, oh, I haven't configured the host name. Hold on. Might as well grab the other export. (1096.01) 443. Oh, it actually just says host IP, so let's not get too creative here. And then the export the port, which is 443 in your case. And then go back to our writing the configuration into Vault here. And this should enable Kubernetes auth. Woohoo! So I do vault read auth Kubernetes config. Probably already, well, may have already had it, but I don't see where it's actually storing that. Yeah, I don't see where it's actually storing that JWT. Now, this is cool. This is actually going to be where we relate the service account to a particular path inside of Vault. So, because we have our test policy, we saw what our policy was, and we know that the token is we're going to issue for this thing. When it actually issues one, it's going to be for 24 hours. So we'll talk through that here in a sec when we get on the big screen here. So, so what we're doing now, earlier we created a policy. And in that policy, we're saying we're going to allow the path, KV anything, the capability of read. So now we're actually going to leverage that policy, and we're going to provide that access to a service account that is known as KV Vault, and that service account will be in the namespace demo. And the token that we issue that service account, when we go through that flow, will be good for 24 hours. So now it means, like we're going to go through this further, but basically what this means is that I have now the ability as that service account to authenticate to Vault. The token that Vault will provide me will match the policy that has been given, which will only allow me to read secrets, but it will allow me to read secrets at pretty much any path, right? So that's what we've got defined so far. Let's do this. See what we get. Not sure that we have it, but let's take a look anyway. Oh, we do. Cool. It must have been brought in as part of the operator. So now we want to create this app binding. And we'll talk a little bit more about app bindings. I think this is actually a relatively new idea that I've seen the apps code folks starting to work on. I haven't actually explored it myself too much as far as what's happening here, But I think it's actually a way to ensure that you have a reasonable implementation of providing access to particular things back and forth between entities within your Kubernetes cluster, kind of a better security model for that. Yeah, so there's the app binding that we want to create. It's going to be in the Vault app binding. It's going to be created in the namespace demo. The client config URL, what's that? And then we have parameters kube vault, v1 alpha 1, which is right, vault server configuration, use pod service for CSI driver. But what is this? Let's go back to our docs. Replace this with the vault URL. Presumably, that vault URL would be the one inside of the cluster, which I think means we would have to echo. That's not gonna work. So kubectl get vault server demo show YAML. Does this guy give me a vault URL? When describing this it doesn't give it to me, but we know what it is, right? Like when we looked at the secret earlier, we could actually kind of derive the URL from that, because that's actually going to be the interesting bit. So this is actually looking at this is actually looking at the certificate that's in front of Vault, and the certificate is going to have as part of its SANs everything I need to build to the URL here, right? Like we know that we're listening on port 8200. We know that this is the DNS name, so we can actually interact with Vault using that from within the scope of this app binding. So let's go ahead and edit that. Probably going to need something in client config that is going to make it so that we don't care about the TLS side of things. But let's see if we get anything with that. So if I do kubectl apply -f app binding, get app bindings -n demo. So this is a Vault configuration. Vault is configured at this path. This may actually be a discovery thing that they're doing here. So what this allows me to do is say, this is the auth path, this is the KB role, the policy controller role. Cool. Well, let's see where we get next. Okay, so we have the app binding. Now it says mount secrets into Kubernetes pod. I mean, it feels a little bit like draw the rest of the fish, but let's give it a try. We're going to have to create a storage class. That's our provisioner. It's going to be demo vault app, KB my secret. This is a secret that we created earlier. Let's go ahead and do that. So kubectl apply -f CSI storage class. So now we can see our storage class is Vault KB storage. We have one there. So let's look at the CSI PBC. So this is leveraging the Vault KB storage class and asking for name CSI namespace PBC. I don't see how it knows what to grab yet, but maybe that'll make sense here in a sec. So we'll keep going here. But before we do that, let's do kubectl describe storage class. And no events, reclaim policy delete. Oh, that's because this is the reason it knows what to get is because we're defining it in the parameters of the storage class. So we're saying it's the KV engine, the path KV, the ref is demo vault. And this is where we are defining that's where it's getting the app binding stuff, right? This is where we're referring to the app binding. And then the secret is my secret. That's pretty cool. So I do kubectl get app binding. Vault app. That might just not work because you see how it says it's referring to demo vault app, and I have it defined as demo vault app dash o YAML. Yeah, so the name of this is actually not in line with the name. That might burn us here in a little bit, but let's see. It'll be kind of interesting. We're going to come back to that if it's broken. Okay. So, we created a storage class. We created that storage class in the, I believe, storage classes are not defined within the scope of a namespace. It's not namespaced. If I do get API resources, I can see that storage classes are not namespaced, which means that they can only be accessed at a cluster level. And that's another one of those boundaries, like for things like your access stuff, right? We can limit access to the ability to read, write, and mess with storage classes to things that only have like a cluster view of the world, not to the namespace view. So that's a good thing. And that's actually kind of part of why I think it makes sense to actually define like what secrets you're actually accessing up at the storage class. So that's actually a pretty cool thing. All right, so we got our storage class defined. We got our service account defined. We have CSI, PBC defined. Bulk KB storage. We have, let's take a look at the CSI app YAML. This is the app. BusyBox, going to mount it, kick it up. And this will be making the persistent volume claim against that PBC. All right, so let's go ahead and go back to the docs, see what it wants to do us next. Wants us to do next. So then it says, go ahead and create the PBC. And then create the pod. But you know what's up here? let's keep going. So, got kubectl, create CSI PVC, sorry, apply -f, get PVC, -n demo. I think this is going to fail because of that mapping that we talked about before, but let's take a look at it. Kubectl. Waiting for volume to be created by the external provisioner, this guy, or manually by the systems administrator. And that's repeating, that's happening more times. So kubectl get pod-n kube system. Logs -n system. Okay, so what I'm looking for now is where I can find the logs for the thing that it's going to make this volume stuff work. So if I do kubectl get, let's look at that storage class again. So cat CSI storage class. Provisioner is secrets CSI kube vaults. Which I would presume to be part of the operator or possibly part of the vault controller. So if we do get pod-n kube system, no, demo. Logs, because what I want to find is the error that's telling me that how it got messed up. So, vault. We already got that figured out. That's the Prometheus exporter for vaults. Kubectl get CRD. So I see the app binding. I don't yet. What I'm looking for right now is I'm looking for the thing that would do that mounting. So if I do kubectl get pvc-n demo, you see it's pending, and I don't get what would actually make that do anything. Like, I'm not sure where that would come from. I don't know where the code sits that would actually make that mount. It's a CSI, but I don't think I've actually installed anything that would satisfy that. I see the app bindings, app catalog, apps code thing. I see the vault server configuration. But I don't see where I would have installed the mechanism to do this work. Let's see who's with us today. Ref name should be demo vault app, not demo vault app. Yeah, agreed. Yeah, that's what I was looking for. It's a CSI driver, but it doesn't actually describe that here in this document. So where is the CSI driver? We're using the CSI driver. So where's that CSI driver at? Let's take a look back at our docs and see. What's the Vault installer? Again, gotta be here somewhere. Ah, now we're getting somewhere. CS node infos, okay. Let's go back to our docs. But I think we actually managed to jump ahead a little bit. And that happens. So docs, guides. Nope. Setup. CSI driver. Install. All right. Here's what we missed, I think. So this is for actually installing the CSI driver. I'm going to go ahead and use a script to do this. Yeah, that's what I'm looking for. It's a CSI Vault *** pod running in the kube system namespace. Okay. Here are the options to the script that I could grab. Let's just go ahead and grab the script right off. It's actually already stored apparently in the hack deployed. Okay, so. Yeah, that's what I was looking for. Okay, so let's grab that. I am running a 113 cluster. So let's look at this install script. So this is going to driver CRDs are CSI drivers and CSI node infos. It's going to use my current kube config. There's a cleanup command option also, which is pretty cool. The apps code environment tells it whether it's prod or some other environment, presumably to like enable more logging or that sort of thing. Tries to determine if, or one of the functions in here is to determine whether it's part of a Git repo, to detect the tag. If one SSL is already present. We do a bunch of exporting of stuff, basically setting things that we're probably going to be using inside of the rest of the script here. Environments that we can actually overwrite, which I like, like basically exposing all of the things that we could pass in, to the user. So if they want to change it or something, they can. Setting a priority class, pretty cool stuff. It's a well-written bash script, I have to say. Monitoring. Now for the good stuff. All right. That's the uninstall. That's the install. Interesting that they're not using, but I don't think they're using. Yeah, they're creating a CA for it. Kind of interesting that they don't leverage the cluster CA for that or provide that option. So that might be kind of an interesting thing to kind of talk about, is leveraging the in-cluster CA for this stuff. But anyway, let's go ahead and do our install. Bash-x install.sh. All right, so now if I do kubectl get pod -n kube system, we should see these guys starting up. Now we're talking. Okay, so we've got our vault node controller and vault CSI vault node controller, vault controller and CSI vault node. Okay, now kubectl get pbc-n demo. Hey, it worked. So maybe that typo wasn't such a big deal. Kubectl get describe pbc CSI pbc-n demo. So provisioning 39 seconds ago, secrets CSI vault, CSI controller did it. I'm surprised that that didn't fail because of the whole mismatch that we talked about before. A little surprised by that. All right. Let us go ahead and get back into our guides. No. Reference. CSI driver. Docs. Examples. CSI driver. KB. So we now have a volume. Let's go ahead and spin up our pod and see what we get. So if we do kubectl apply-f CSI app, kubectl exec ti bars -n demo my pod in bash. Oh, still creating. While we're waiting for that guy to start up, let's go ahead and look at the comments, see how you're all doing over there. So, yes, you're right. Needed to install the CSI driver. So vault operator here is only covering the installation. Yeah, exactly. I thought maybe it was conflating the two of them. It makes sense that CSI would be different. Is there a reason why we wouldn't have an operator to help maintain this bit for us? We kind of do. It is actually, if you look at the CSI thing, it's actually managing that side as well. So, as you deploy vault with a vault operator, set up app binding and role, follow this doc. Yep, got that part. And don't need to configure the cluster twice. Yeah. Ah, that's what it is. So it is a discovery thing. That is pretty cool. Okay, that's kind of what I thought it was. Get pod. So it's taking a little while to create. Let's do kubectl get pod or describe pod -n demo my pod. Pod name not found. Interesting error. PVC failed for volume PVC XSX pod name not found. That's cool. So our volumes are this CSI PVC and then the vault token. Actually, that's just our service account. We told it to use. Okay. kubectl delete pod. So maybe this is the problem, but let's do this. Let's see what kind of logs we get from the thing that would be creating that mount. Let's see if this is the reason why it's failing. So kubectl get pod -n kube system --show labels. So we have our CSI Vault controller and our two CSI Vault nodes. They are all app CSI Vault, so we'll do kubectl logs -n kube system -l app CSI Vault. Guy's not so happy. Wait, it is actually able to connect to CSI SOC. And it's doing get plugin info. It's just like it's kind of redoing that over and over again. Let's take a look at the other pod in here. Our other pod is node driver registrar. We see plugin is registered. Okay, so that's good. You know what I'm curious about? What if we do kubectl? Let's just take a look at what this thing actually is. Get pod -n kube system -oy-l app equals. We'll get to those logs in a sec, but we're getting somewhere. The app is CSI Vault. Aha! Which makes sense, actually. So what this is telling us is, yeah. So because it's a CSI implementation, you have your controller at the top that's doing the heavy lifting, but then you also have you have to have something that is going to implement that volume on the nodes. So where you see CSI Vault node, that's going to be one per node, right? So for every node, I will have one of these CSI instances running with mount paths to that underlying node and access to actually register that CSI piece. So that makes a lot of sense. That's actually pretty darn cool. So let's look at the logs for the CSI Vault controller. I bet you that is where we will find that typo thing happening. So kubectl logs -n kube system and CSI provisioner. So this is saying creating ref demo vault app, which shouldn't work. Accessible topology, no key literal, size cache 0. Oh, so it did it, but there was nothing in it. And succeeded, demo, provisioning succeeded. Okay, so the provisioner did its thing. Cluster. Connected to the CSI sock, created secret CSI key vault. Looks like we're able to successfully authenticate. It's marking the volume as attached. Could all get PVC-n demo. So we still see it bound. We could describe PVC. Okay, well, what if we throw our pod back up again? Get all pod-f CSI app. Get pods. So it looks like the fallout will be that once we actually get access, it's still not going. Kubectl describe pod-n demo my pod. Attach volume successful. Fails mount. So we were able to attach the volume, but then the kubelet was not able to mount it because it says the pod name is not found. Well, that's something. Get O-O wide. All right, so what I want to do next is I want to jump in and like take a look at what's actually on that volume, on that node. So let's see if we can do that. We also know it's landing on 10.02.220. So if we do kubectl get pod-n kube system grep dash oy grep 220. You can see this is the vault node that's landing there. So kubectl logs -n kube system CSI vault plugin. We're still getting these errors. It's like ready and then tries to get this secret. This might be a fallout of the actual naming thing. But it is interesting. So let's try just fixing that. Boom. Kubectl delete -f app, well, no. CSI app YAML. PVC storage class. Actually, cat app binding. So this is being set to my Vault demo, Vault app, cat CSI storage class. That's where our typo is. Okay. So kubectl delete storage class. Vim, there, edit our storage class here. We'll enter our dash, and then let's do kubectl create storage class, or create dash f CSI storage class, PVC. Get pvc-n demo, bound, create, let's just look at the pod description real quick. I feel like we're so close to getting this to work. App YAML, my bot volume, CSI PVC, kubectl get pvc-n demo, CSI PVC kubectl, apply-f, CSI app YAML, kubectl exec, or describe pod-n demo. Nah, still didn't mount. Same problem. It's looking like the mount itself is actually failing, and that's interesting. Anybody got any ideas? YAML syntax, storage class needs to rep. Yep, got that already. Need to rep. You need to rename Vault app to, yeah, I did that. And thank you. Looks like there's actually something probably lower level on the keyboard that somehow messed up. So if we do AWS, let's look at this. So back over here to Vault, or back over to AWS. Pull up our EC2 cluster. For running hosts, we're going to jump into our Bastion. Dynamic mount volume for pod. Grep my pod demo. So it sees the volume registered, but it's unable to mount it. So our application was called again. Our container is called mypod demo. So docker ps. Good. It's not actually even getting to the point where it's there. So volume. I call it volume. Yeah, you can see the tokens that are stored there, but not the actual content. Maybe because the CSI driver is actually trying to mount it directly, which would be very cool. And it was something I'd love to show off, but doesn't seem to be working. So, yeah. Good call, Bogdan. That's exactly what we're doing. And what I'm trying to figure out from here, I suspect it's just going to be some weird typo thing or something. There's our error right there. Mount volume secret found for unique name. Yeah. It's all storing it there in that socket. It's behind the socket. It's running in code, so it's in memory rather than sitting in. Yeah. All right. Well, I think we're pretty much at a checkmate at this point because I can't seem to get to the volume, and I can't seem to get to figure out why. So, all right. Well. Looks like we win some, we lose some. kubectl get pod -n kube system. And then demo. Yeah, kubectl logs. Sadly, we're running into this issue. And the error is really fascinating because the error is that the kubelet is complaining that the pod name is not found. So it's like somehow the CSI, my presumption is that the CSI driver, when trying to mount this volume, is not able to identify the actual pod that's running. And so it's not landing it. And this was the actual error that we saw. Well, there's the mount path for KubeVault's PVC. Oh, weird. Okay. So we just saw our path in our error volume. Let's see if we actually even see it here though. Look. So that's the path on the system. It's just a record of what was being mounted where, but it's not actually making it available. There's the global mount. All right, well, looks like we're kind of stuck on that part of it. So that's unfortunate, but let's keep moving, I guess. That's about as far as we're going to be able to get with KubeVault today, I think. It is now 3:22. Okay, well, thank you all so much for your time. And I'll revisit this again with KMS at a future time. So thanks a bunch. See you next time.